55 Cancri E should not have a sky. It orbits its star in under 18 hours, close enough that its dayside surface crosses 2400 Kelvin. Every standard model of atmospheric escape says that at this distance, from a star this bright, any volatile envelope should have boiled away billions of years ago. The rock should be bare. JWST looked anyway. Its NIRCam and MIRI instruments captured a transmission and emission spectrum from the planet's thin sliver of light, and what came back matched carbon monoxide and carbon dioxide, gases that, by the physics we trust, have no business surviving there. The easy explanation is contamination or noise. Instruments make mistakes, and hot, rocky exoplanets are hard targets. But the same carbon signature showed up across multiple secondary eclipse observations when the planet passes behind its star and its own thermal glow briefly disappears. The eclipse depths lined up each time, the signal held, so noise doesn't explain what was measured. Something is producing that spectral fingerprint, and it doesn't look like instrumental error. Here the scale expands. A planet this close to its star doesn't just lose atmosphere to heat. Stellar wind, ultraviolet flux, and the star's own magnetic activity strip volatiles from the top of any atmosphere continuously, not once, but for billions of years straight. Atmospheric escape at this proximity isn't a slow leak. It's closer to erosion under a fire hose. That's the first hard limit. A static model of a single primordial atmosphere can't explain a signal this persistent. If 55 Cancri E ever had a thick early atmosphere, standard escape physics says it should be long gone by now. So either the atmosphere we're seeing isn't the original one, or it isn't a true atmosphere in the conventional sense at all. One disciplined possibility is a secondary atmosphere. The planet's dayside is hot enough to sustain an ocean of molten silicate rock. If that magma ocean keeps releasing volcanic gases, outgassing could resupply carbon dioxide and carbon monoxide as fast as radiation strips them away. Not a fossil atmosphere, a working one, replenished in real time, more like a planetary lung fighting a losing chemical war and somehow holding a stalemate. That explanation has its own limit too. Volcanic outgassing at this scale, on a tidally stressed, ultra-short period world, has never been directly observed or fully modeled from the ground. We're inferring a mechanism here, not confirming one. A second bounded possibility is stranger. Carbon may not be escaping as free gas at all. It could be dissolving directly into the molten silicate, held in the magma ocean, and bled back to the surface slowly, through chemistry between rock and atmosphere that no laboratory has replicated at these temperatures and pressures. If that's what's happening, JWST may be detecting a thin equilibrium layer, not a true evolving atmosphere. More like the surface chemical signature of a planet still deciding what state it wants to be in. Neither model is clean. Neither is confirmed. Both would force a rewrite of where the line sits between a bare lava world and a planet that can hold on to gas. The heat difference between dayside and nightside adds another constraint. If 55 Cancri E had no atmosphere at all, heat would stay locked on the scorched side, facing its star, with almost nothing carried to the dark side. The data shows some redistribution, but not as much as a thick, circulating atmosphere would produce. That middle ground is exactly what you'd expect from a thin, chemically active envelope. Not a dead rock and not a stable, thick sky either. What this changes is specific. If the carbon signature holds up as atmospheric, it means the boundary for atmospheric survival near hot stars sits closer in than current escape models allow. A whole class of ultra-short period rocky planets, quietly written off as geologically dead, may be undergoing active chemical exchange between mantle and sky. Not alive in any biological sense, just less finished than we assumed. The remaining silence is real too. JWST's current data can't yet tell the difference between a persistent volcanic atmosphere and a surface chemistry illusion mimicking one. Cycle 4 phase curves are designed to settle exactly that, by tracking how the signal changes across the planet's full orbit instead of at a single eclipse. Subscribe if you want that result, followed with the same restraint, whichever way the carbon points. Until then, 55 Cancri A sits in an unresolved category, a planet that should be bare, showing a signal that says otherwise, and no clean way yet to tell if it's breathing or just refusing to stay still.